Dear students, myself Jitendra Jain. Today we will discuss about simple linear regression method of data analysis. The data when we acquire in research may have one dimension, may have two-dimensional data or multi-dimensional. So accordingly, different techniques are there for the data analysis. So today, for the two-dimensional data, we'll see how simple regression techniques can be used. In linear regression, each observation consists of two values. One value is for the dependent variable and one value is for the independent variable. So in this simple linear regression, a straight line approximates the relationship between the dependent variable and the independent variable. Now, in this lecture, we'll see how the equation of the line can be obtained through Microsoft Excel as well as through MATLAB. So, suppose I have independent variable as x and dependent variable as y. So, I have to find simple regression of y on x. Y equals to a plus bx. So I have to find this line equation by fitting this line on this data. So for this, we require following elements. Summation of y, n is here 1, 2, 3, 4, 5. 5 elements are there in each vector. Then summation of x, summation of x into y, and summation of x square. So let us see how these are calculated. X square equals to this is the x square. Now x into y, that is a2 into b2. Now here sum of elements of x and sum of y, sum of x square and sum of xy. So according to this formula, we can write the equation summation of y, that is 40, equals to 5, since n equals to 5 here. So 5 into a plus sigma xi, that is 30, b. Second equation, summation of x into y, 2 and 4, equals a summation of xi, that is 30, 30 into a, plus summation of xi square, 220, 220 to b. Now, by solving these two equations, we obtain a equals to 11.9 and b equals to minus 0.65. So our equation becomes y equals to 11.9 minus 0.65 x. This is the manual way to calculate the simple regression of y on x. Now there are some inbuilt functions in MATLAB through which we can also find the same equation. Say, let us see how we can obtain through the functions. Now see, in the insert tab, there is a scatter plot. Click on the scatter plot and the types of plots are there. If we calculate this one, then you can see the same equation y equals to minus 0.65x plus 11.9. And this is the R square. That is the correlation between these two data sets. And you can see this is the straight line fitting between these two data sets. Now, in the data analysis step, there is a regression here. Click on the regression. Then on the output, input y range, input x range, and label. Yes, I have selected here labels also. So, okay. Now we can see here. This is the intercept 11.9. That is the value of A. And value of B, we can see here, it's a point minus 0.65, the value of A. And R square, we can see 0.845 that we already obtained here. The value of A and B. Now we can calculate these regression values in MATLAB also. Suppose X is there. So we can enter the value of here 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And y is 11, 8, 9, 7, 5. Y is 11, 8, 9, 7, 5. Now, using a simple command, R D A regression, regression XY. Now you can see here, this is the correlation between the two data sets And again we can see B is here minus 0.65 and A is 11.9. So in MATLAB we can also have function regression. In addition to that, scatter plot is also there in MATLAB. For this, you just write as scatter between x and y. These data points we obtained here. Now in the tools, basic fitting, then the linear fitting we require. So an equation, now we can see the same value of the intercept and A and B we obtained through this MATLAB. So with these methods, you can find the simple linear regression on any data sets. Thank you.